this lecture class, I will discuss about series and parallel operations of SCRs. Whenever rating of the thyristor is less than the supply voltage, then thyristors are to be connected in series. And if the current flowing through the system is more than the current rating of the SCRs, then number of SCRs are connected in parallel to share the current. But it is not so simple to connect these SCRs in series and in parallel. So different issues in connecting the SCRs in series and parallel I am going to discuss today. Till now, available rating of SCR is about 10 kilovolt and 3 kiloampere rating. Suppose you want to use a SCR in a 100 kilovolt system, then as 100 kilovolt SCR is not available, then more number of SCRs you have to connect in series to share the supply voltage. Likewise, if the supply current is more than 3 kiloampere, then number of SCRs are to be connected in parallel to share the current. For very high power applications, that means high voltage and high current applications, series and parallel both operations can be done, but the system becomes very much complex. Now, in every case, rating of the SCR should be utilized properly, or full utilization of rating should be there. That means, suppose you want to use a thyristor of rating 1 kilovolt and 50 ampere, and that thyristor you have used across 100 volt and 50 ampere application, then the thyristor is not fully utilized. The system becomes costlier. That's why a term string efficiency is used here. It is used for measuring the degree of utilization of SCRs. It is generally less than 1 and is defined as actual voltage or current rating of the whole string divided by individual voltage or current rating of one SCR multiplied by number of SCRs in the string. In case of series connected SCRs, actual voltage rating will be considered, and in parallel connected SCRs, current rating will be considered. One more term is derating factor. It is equal to 1 minus string efficiency. It is directly related to reliability of the system. That means if you want to increase the reliability of the series or parallel operations of SCR, then full utilization of rating of the SCRs will be reduced. That means you will not be able to fully utilize the SCRs. That means if derating factor is more, then utilization of SCR will be reduced. SCRs connected in string must have identical IV characteristics. This is impossible to achieve because two SCRs of same rating and same specifications don't have similar IV characteristics. This we will discuss in detail. Let's see. Supply voltage of 2900 volt is connected across 6 SCRs. When the SCRs are off, then this 2.9 kilovolt is shared by the 6 SCRs, and the string efficiency is 2900 divided by number of SCRs into rating of individual SCR, 500 volt. So 500 volt I have considered the rating of each SCR multiplied by 100 is equal to 96.67. So string efficiency is 96.67%. Then derating factor is equal to 1 minus 0.9667, that is equal to 3.33%. Now in the same string, if one more SCR is connected, then number of SCRs become 7 and the string efficiency becomes 82.86 and derating factor is increased to 17.14. That means the burden of 2.9 kilovolt is shared by 7 thyristors in case 2. So case 2 is more reliable, but degree of utilization of SCR is less in case 2. As the cost of the SCR is more, so it is better to choose second case than case 1. The reason behind it is that because of any fault in the system or any reason, if one of the SCR triggers earlier than other 5 SCRs, as soon as the SCR triggers, the voltage across the SCR will become 0. Then 2.9 kilovolt will be shared by remaining 5 SCRs and the rating of the SCR is 500 volt. 5 SCRs as a whole can share maximum 2.5 kilovolt. So all the 6 SCRs will get damaged. So it is better to go for better reliability than to increase the degree of utilization of the SCRs. Voltage shared by the two SCRs may not be equal because of the inherent variations in their characteristics. The reason behind it is that at any instant of time, the number of carriers across the individual thyristors, though they have same rating, same part number, same specifications, are not equal. Because of that, internal resistance offered by the thyristors are different. So this is one of the major issue in connecting SCRs in series. So the voltage shared by the SCRs will not be same. It will not be equally divided among the two SCRs. If 100 volt supply is given across the two SCRs, then 50 volt is not shared by thyristor number 1 and thyristor number 2. Then one of the SCR may be fully utilized and other SCR is underutilized. So this is one of the major issue in connecting SCRs in series. So this issue we will solve in today's class. Let's take an example. The two thyristors 1 and 2 have similar IV characteristics. Same breakdown voltage, VB01 is equal to VB02. Almost same latching current and holding current. When the SCRs are off, then same leakage current will flow through the two SCRs. In the graph you can see I0 is the leakage current. Now this leakage current intersects the thyristor number 1 and thyristor number 2. So graph of thyristor number 1 and thyristor number 2, you can compare that the leakage current intersect the thyristor number 1 graph at V1, which is lesser than V2. So the leakage current is same, though the voltage shared by the two thyristors are V1 and V2. It indicates that internal resistance offered by thyristor number 1 and thyristor number 2 are different. Let's discuss in more detail. I0 is the leakage current of the SCR. Let's take rated voltage of the SCRs are V2. One of the SCR is selected as the reference one, so rated voltage in this case is V2. For the same leakage current, leakage resistance of SCR number 1 is equal to V1 by I0, and leakage resistance of SCR number 2 is equal to V2 by I0. So leakage resistance of SCR number 2 is more than leakage resistance of SCR number 1. So SCR number 2 will share more voltage than SCR number 1. So SCR number 2 can be assumed that is more utilized than SCR number 1. And the two SCRs can support a maximum voltage of V1 plus V2 and not 2V2. And the string efficiency is equal to V1 plus V2 by 2V2 is less than 1. So from this graph we can conclude that though SCRs have same rating, same specifications, identical characteristics, but voltage shared by each is not the same. Now, to make the voltage shared by each of these two thyristors equal, one option is that connect shunt resistance across thyristor number 1 and thyristor number 2 in such a way the equivalent resistance across thyristor number 1 and equivalent resistance across thyristor number 2 are equal. Then the resistance offered by equivalent combination of thyristor and resistance of individual thyristors will be equal. Then the voltage shared will be equal. But this system becomes too much complex if number of SCRs are more in the system, because individually these resistances are to be found out. Then alternating solution is that design a shunt resistance in such a way that equivalent resistance offered by the thyristor which is blocking maximum voltage must be equal to the or close to the other thyristors sharing lesser voltage. So this is the main concept behind it, that instead of going for calculating different value of resistances for each thyristors, select a worst case condition. Out of n number of thyristors, which one is sharing maximum voltage? The thyristor sharing maximum voltage is to be considered as the reference one. Let's find out the value of this R so that voltage shared by the SCRs can be made equal. A DC voltage is connected across n number of SCRs. SCR number 1, 2, 3 up to n number of SCRs. Out of these, the SCR which is blocking maximum voltage is considered as SCR number 1, and other SCRs are considered to share almost equal voltage less than the maximum voltage. As the SCR number 1 is blocking maximum voltage, so SCR number 1 will have minimum leakage current. Say it is IB minimum. So string current is I, then current through first R from the left hand side you can see I minus IB minimum. and leakage current through remaining n minus 1 SCRs is equal to IB maximum. Then current through remaining R from left hand side is equal to string current minus IB maximum, I minus IB maximum. Now voltage across SCR number 1 is equal to R into I minus IB minimum, and voltage across each of n minus 1 number of SCRs is equal to R into I minus IB maximum. If battery voltage is V, then V equal to R into I minus IB minimum plus n minus 1 into R into I minus IB maximum. Here neglecting the voltage drop across the load resistance, because the leakage current is very low, so the voltage drop across the load resistance can be considered as negligible, so not considering. So supply voltage equal to voltage across a number of SCRs. So first SCR voltage drop is R into I minus IB minimum, and remaining n minus 1 number of SCRs voltage drop is n minus 1 into R into I minus IB maximum. Now you can see that current through first resistance, it is considered as I1, and I1 is equal to I minus IB minimum. So in this voltage equation, I can be replaced as I equal to I1 plus IB minimum minus IB maximum. Then in next line you will see VB max plus n minus 1 into RI1 minus n minus 1 into R delta IB. Here delta IB is equal to IB maximum minus IB minimum. In data sheet generally IB minimum is not given, only IB maximum is given. Then in that case IB minimum can be considered as 0, then delta IB is equal to IB maximum. Now next line, RI1 is equal to VB max. Then solving this equation number 1, you will get R is equal to n into VB max minus V by n minus 1 into delta IB. So for n number of SCRs having voltage rating of individual SCRs VB maximum minus string voltage divided by n minus 1 into delta IB. So this will give you the value of resistance is to be connected across individual SCRs to make the equivalent resistance offered by these SCRs almost equal, so that the voltage shared by these SCRs will be almost equal. So this condition is considered based on thyristors are off, or steady state condition, or you can say static condition. That's why the resistance is known as static equalizing circuit. So today we have discussed about series operation of SCR, the issues related to series connection of thyristors, how the voltage is not shared equally by number of SCRs connected in series. Then a method we have discussed by connecting a shunt resistance, a same value of shunt resistance across all the SCRs to equalize the voltage shared by the SCRs, instead of finding different resistances for individual SCRs. That will make the system much more complex. So the second method, or shunt resistance method, is more suitable in case of series connection of SCRs. And in the steady state, that means in off condition only, If the thyristor is on, then there will be different condition that we will see later on. Thank you.